Got with me my fellow V expert, Eric Siebert. Eric, why don't you introduce people, tell people how to find you?
Sure, I'm Eric Siebert. I'm a VMware V expert. I run the website vSphereLand.com. I also work for HP Storage, Solutions Manager. My focus is on VMware virtualization, dealing with all of our HP Storage products.
And if you don't know, you can find my blog. It's at hp.com/storage/blog. And Eric, I wanted to talk to you because I know you've got a session tomorrow here at VMworld.
Right.
In fact, if anybody is here at VMworld, why don't you tell them when and give them the details for when your session is?
Sure. It's tomorrow, Tuesday, at 5 to 6, I believe. The topic is the top 10 things you must know about storage for vSphere, and it's a compilation of just various different things you must know about storage for vSphere, ranging from things like storage protocols, best practices, design considerations, all the different types of things that people have questions about when they have storage for vSphere. So, pretty a lot packed in there in that. So if it's full right now, but if there's probably the standby line, if people want to see it, they can probably get in and be a good session.
Yeah, and that's why I wanted you to tell people. We got cameras right in front there. You got to step out of the camera. Thanks. So, in fact, that's why I wanted to do this with you, because I knew your session is full. And certainly there's always the opportunity to go stand in a line and get in, and I think your session is going to be pretty packed. But to get some of the information out from your session, I thought it'd be helpful for us to, we can't do all 10 things in the 30 minutes we have here, but we can maybe hit 4 or 5 of them, and we'll talk about 4 or 5 of them, and then maybe what we can do is we'll actually do a podcast together where you can talk about all 10 of them.
Yeah, in detail.
So let's start with, and I'm going to look at your slides here so that I can make sure I hit the things I wanted to hit. So the first thing is where you start your presentation is to talk about why. Oh, hi there.
That's a distraction. Put a fence up here, and
Alistair is going to be a bodyguard here for us to stop people from walking through. So let's start by talking about why storage is such a critical resource. I know for most people that understand VMware and work with it every day, they get why storage is such a critical resource, but especially the thing I think I want you to talk about is VM density, and how is storage so important to getting a VM density?
Sure, yeah, if you look at all the resources on a host and that a VM requires, those 4 resource groups, storage is really typically the one that's not a local resource, and that you have many hosts all vying to access that one shared resource, and that. So storage really becomes a focal point in a vSphere environment that typically becomes a bottleneck because you have so many hosts. And with a host, typically all the other resources are local to the host. If you look at CPU and memory and network, they're all local to that host. So storage really becomes a driver that drives VM density, because typically it's the one resource that you have, limited, it's shared in that. So really, when you look at storage, it really becomes a driver for what you can get out of your storage for VM density.
And today we just heard about, a little bit at least, about vSphere 5.5. I suspect you probably know more about it, but one of the things they've done is they've really expanded it. I mean, it was like double everything, right? Except for
every year.
Except for the capacity of what you can have on a VMDK. That was times 32, I think, right? But how does that affect VM density? Does this make it a bigger problem now?
Yeah, it even drives greater resource. Because if you look at the monster VMs that we are capable of today, and that there's even more demand than on the storage array, because we're putting so many other host resources into play in that storage is just getting hit more and more. There's more workloads that are more concentrated. You got more random I/O all coming at your storage array. So storage really becomes that. And if you look at storage compared to the other resources, it's the one resource that's mechanical in a lot of cases, and that with spinning disks and that. So it's a little bit of a slower resource than that. So really, storage becomes that driver to VM density, and really becomes sort of the weak point of the resources that can really drive those master VMs, and that you have to have adequate capacity to really feed those VMs.
Well, if we have time, we may hit that topic of the new storage types that don't have spinning media, and maybe talk about storage considerations for SSD. But we've got some other ones we want to hit first. One that I think is interesting that you do a really good job talking about is what protocol to pick. There's lots of protocol choices. What are some of the choices, and what are the considerations for picking file or block?
Yeah, it comes down to file or block, and within that you have iSCSI, Fibre Channel, and NAS, and that. And often people are confused about which one is the best storage protocol for a VMware environment, and the answer is there really isn't the best. If you look at the VMware documentation, they're not going to come right out and say this is the best storage protocol to use in a VMware environment. Each protocol has, obviously their architectural type quirks in that both have benefits and cons against them. But each protocol basically is doing the same thing. It's driving your data from the host to the storage array, from point A to point B. That's really the mission of a storage protocol. It's really just to get your data from point to point. Different protocols are different means to the same end. So essentially, the protocol that you use will have some quirks that you should know about, and maybe some limitations, and that will help you maybe decide which protocol works best in your own environment.
Well, let me ask you about one of the limitations. I actually was just talking to Edward, who we both know, and he was talking about at his employer, the security people won't even let them consider NFS because of some of the security issues with NFS. He spoke a little bit about it, but why is NFS maybe less secure as a protocol?
Well, I don't know necessarily less secure. I mean, obviously there's best practices for securing your protocols, isolating the traffic and that.
That's what he talked about.
But the security controls aren't as strong as maybe like an iSCSI, where you have the authentication, the encryption, CHAP, and all that stuff that you have in there to better properly secure it. And that, but I think as long as you isolate a lot of that traffic and that, you can keep just about any protocol secure if you're not opening up people, avenues for people to be able to get in there and do something with that protocol and sniff it.
So I don't want to spend too much more time on this one, but I think in your presentation, you're going to talk about strengths and weaknesses. What are some of the big ones that jump out at you, strengths and weaknesses of the different options?
Yeah, kind of like a superpower and a kryptonite for each one. And if you look at each one, they all kind of stand out in a certain way. Fibre Channel is, obviously its best strengths is it's in a lot of data centers. It's been the enterprise go-to SAN protocol for a long time. Great performance, low latency, and that you can't go wrong with Fibre Channel. The con, though, oftentimes, cost becomes a concern with Fibre Channel. Expertise, your skill sets, often, takes a little bit more to be able to configure and manage that network. With iSCSI and that, uses a standard Ethernet component, so it's fairly simple, easy to use, set up, and your existing infrastructure. But it typically doesn't scale as great as Fibre Channel does. With NAS, there's some unique features in NAS and that with some of the file locking that it does, and kind of that offloading, that data processing, and all that file management to the storage array from the host. Weakness, some of the load balancing and high availability. There's no support for PNFS right now and vSphere in that, so let's say that's kind of a little bit of a rundown.
So one of the other ones that you talk about is storage performance, and this is a pretty deep topic. I mean, obviously storage is a big component to performance because every VM sits on a storage device, but what are some of the things that you would give as advice when you consider storage performance?
Yeah, I'd first off say understand storage performance in general and know, that I/O, the journey that I/O has to take to get from a VM all the way to the storage array. A lot of potential places for bottlenecks on that journey and that, all the way from that virtual SCSI adapter inside of a VM, through the VM kernel, through the storage array and back, and that kind of understand, where the different components are of that journey, where potential bottlenecks can form, and where you kind of measure some of the latencies in that to understand, where you may have a bottleneck in your environment.
So you mentioned disk latency, and I was looking at this slide that you're going to present. It talks about all the components. This maybe getting a little deep, but I thought this was kind of interesting. Where are the components of latency?
Yeah,
the terms here that you talk about in your presentation.
Yeah, a little bit of technical terms, but kind of a high-level overview. The latency is measured all the way from where that I/O enters the VM virtual SCSI adapter all the way to the host. That's a general measurement of latency in that, the total guest latency essentially, how many milliseconds does it take that I/O to make that journey and back. Within that, there's other latencies that are they're measured where you can kind of further pinpoint where a bottleneck may lie, things like the kernel latency. Once it leaves the VM, how long does it spend in the kernel, how long does it spend in the queue, and then finally, how long does it spend in the device in that. And from that, you can kind of judge where you may have a bottleneck and kind of really nail down where you may have an issue in your own environment.
So in terms of what kind of tools do you recommend people use to monitor performance? I know one of the things we just announced is the DC Ops integration that we have, and that I'm playing around with that over the weekend actually, and that would look pretty cool. But besides that, what we have for 3PAR, what other types of tools do you recommend? vCenter
is your obviously go-to tool that really gets you that basic view of storage performance, and that you can turn on more metrics inside of vCenter to kind of see some of the undercover or more deeper metrics in there, especially with things regarding latency and that. So vCenter is a good basic tool for that. Obviously, tools like vCenter Operations are a lot more robust and do a lot more in that. A lot more visual too, where vCenter, you kind of got to know what those stats are, what they mean in that. Not always that easy. With vCenter Ops, it makes it a lot easier because it's a lot more visual tool.
Yeah.
Green, yellow, red. I know what's good, what's bad in that. So it makes it a lot easier to detect that.
Well, the way it graphically presents the performance too. I mean, I'm not a deep technologist, but I just watched looking at it, and there's graphs where you can see IOPS, you can see latency, you can see kilobits per second, and you can look at it.
Like heat maps and all that
the
stuff.
The heat maps, and it just makes it really easy to find the performance metrics.
Yeah, definitely. It goes deeper, and it's a lot more visual to be able to display that information. Other tools, there's a lot of great third-party tools as well, and VMware has a lot of those little niche tools or flings that are focused on performance as well.
Fling, is that kind of like a Bling? Is that?
No, VMware's Bling.
It's Bling. A VMware Bling is called a Fling.
Yeah, it's a little tools they develop, app tools, to be able to do certain tasks that maybe aren't built into vSphere today and that. So, and then finally, ESX Tops. If you really your go-to tool to really dig deep into performance is ESX Top, the command line tool that really helps you drill down and get real-time viewpoint of your metrics.
So another topic that you cover, and I think is going to be one that's a good one for people watching to hear about, is storage is a really critical component in this whole environment. So talk about why high available storage is a critical element to consider when you're designing a VMware environment.
Yeah, sure. One of my favorite lines, I think Stephen Herod said it at one of the VMworlds, at one of the keynotes, is when you put all your eggs in one basket, you need a really, really good basket. And when it comes to storage, and that becomes even more important because if you look at the high availability features that VMware provides you, things like HA and FT, they only protect against a host failure. If your storage fails, those features aren't going to help you at all. So you really need highly available storage to protect you in the event of a storage failure, which really is a single point of failure in your environment. You have one storage array hosting all those VMs, lots of hosts, and so that storage array really becomes that focal point that, if that goes down, all your VMs go down.
So let's talk a little bit about VMSC, because I know I think we're the first iSCSI array
right,
to have
that certification.
VMSC.
Yep.
I always get
Store
tongue
virtual.
twisted on that. With Store Virtual, and now we've got 3PAR with peer persistence having VMSC. What compare VMSC with SRM, and how do those two?
Sure. If you look at the high availability features for VMware and that protect against storage, and that HA and FT all protect against a host failure, VMSC, vSphere's Metro Storage Cluster, and vCenter Site Recovery Manager are the tools that help protect against storage and keeping that highly available as well. Sometimes there's confusion now. What do I use? Do I use VMSC? Do I use SRM? And there are really two specific kind of use cases for both of them. VMSC is designed for more continuous availability. I don't want to suffer an outage at all in that. I want highly available storage all the time. Where SRM is more of a traditional failover to a recovery site solution in that, where I have downtime, things fail over to a recovery site, and then I pick up from there in that. VMSC has become one of the hotter things today because, as I said, that storage does become the weak point in the environment. VMSC eliminates that weak point and really gives you that highly available storage, even continually available storage when you use it in a uniform configuration.
So I said I'm not sure we'll have time to hit it, but I know we're going to have time. So let's hit this one since it's next in your presentation.
Sure.
What's the role of SSD? This is obviously an emerging technology. We've been talking a lot about flash optimized storage on my blog and kind of things that we've done at HP, but what role and how do you see SSD playing into a vSphere environment?
Yeah, SSDs more and more are becoming almost standard in any environment. It's most companies can't afford to implement SSDs across the board. There are some limitations with SSDs and that, but strategically used, they're a good fit for doing things like handling all that unpredictable workloads, handling those peak periods, and really kind of helping to keep the I/O level and being able to have those dips where you're suffering bottlenecks. And that SSD is a great fix for that. When you use them strategically in your environment, a lot of people already have performance problems. They think, okay, I'm just going to throw SSDs in there to try to fix the problem in that. But you really should think about how you're going to use them. Have it as an integral tool. Have some type of tier in your environment. Have some type of strategy for using them. Maybe using an auto tiering product to automatically move hot blocks. Putting whole VMs on an SSD tends to be wasteful in that because a lot of the blocks on a VM aren't needing that high capacity performance in that. So. Really understand some of the limitations around SSDs. Obviously, the write light of an SSD becomes a factor. So make sure you have tools that can monitor that and be proactive with replacing that. And it's basically just use them strategically in that. They're a great piece of the whole storage picture for VMware environments. So just understand their capabilities, limitations, and just plug them in as best you can to get the most benefit out of them.
So there's a couple products in the HP portfolio. Let's hit on a couple of them, because we just announced, actually just a couple weeks ago, the new sublun tiering that the HP Store Virtual VSA has.
Right.
And how does that play into using SSD in a VMware environment?
Yeah, that's a good one, because it gets you that, instead of, like I said, blindly placing whole VMs on SSDs, now you can auto tier, just like we have with 3-power adaptive optimization, to move hot blocks to those tiers, and that it really kind of adds some intelligence to the SSD in that, where now you can just move the blocks that are going to be heavily accessed to that SSD tour and not have everything on there. So you can obviously have limited space in a lot of cases in that, so you want to really get the most of you can out of those SSDs. So having things like that auto tiering, and that can really help you get the most benefit out of SSDs. Yeah,
and let me just throw out there that if you haven't played around with the Store Virtual VSA, there's actually a free trial of that. It's a full featured trial. You can find that at hp.com/go/try VSA. I don't think the version, we've announced the sublun tiering with adaptive optimization, but it's not shipping yet, and it's not on the download site, but coming mid-October. If you wait till then, because it is a 60-day trial, go grab it, play around with the auto tiering. If you've got some SSDs in your environment that you can afford to play around with a little bit, it's a great opportunity to see how the auto tiering works. And we actually just did a podcast on that on my blog, where we had Brad talking about the functionality. Brad Katz is the product manager, and really automatic, set it and forget it kind of auto tiering.
Which is perfect, because you don't have to be a rocket scientist, and you get the most benefit out of that. So it's definitely a good feature to have. Yeah,
in fact, what I told Brad is it reminds me a lot of Auto RAID, which was an older technology in HP back in the 90s that was basically RAID that you didn't have to pick a RAID level. It would write data to RAID 1, and it would put colder read data in RAID 5, and you didn't have to set anything. You just did it, and it did all of it by itself. And this, to me, feels a lot like what that was. So there's a lot of metadata, a lot of analyzing of the data and where the hot data is, and it's all done automatically, so that you, as a storage administrator or as a VMware administrator, you don't have to do any of that.
Yeah.
And that's a big value in that, right?
Yeah, because
you don't want to be managing this stuff.
No, and if you look at the SMB space in that, those people don't know storage that well, so having something that manages itself is a big benefit to them.
Okay, so we may have another topic after this, but this is one I definitely wanted to hit, and this is why thin is in, and staying thin is a big win. So here we're talking about thin provisioning. So why is this one of the topics in your session?
I think thin provisioning is almost something you have to use these days in a VMware environment, because of just the nature of virtual machines, that you're allocating all this disk to a virtual machine, and in almost every case, you're not going to use all that disk, and that it's essentially wasted in there until you you grow up in that, and maybe use part of it in that. But it's a lot of wasted space, so that's just wasted money essentially in that. And thin provisioning gives you the opportunity to only use what you need, despite how much you allocate to the virtual machine. So it's a big win and cost savings and efficiency.
So let me again turn it to an HP side of this. HP 3-power StoreServe with the 3-power ASIC, which it's been a part of the technology for a long time, and what it does, what sets that ASIC apart from the way other people have implemented thin provisioning? What makes it so special with that?
The cool thing, which I think is unique to us, is we actually, in our ASIC, all the blocks, all the writes go through that CPU in the storage array. It looks at all those blocks, it's intelligent, it can examine them, it knows when a 0 comes through. And instead of writing that 0 to disk, it says, hey, it's a 0, I don't need to write that to disk. So what that does is it frees up the storage array, more capacity. I'm not writing that unneeded data to the disk, so I get a lot greater efficiency, a smaller footprint on my storage array, in that it can detect all those 0s automatically and not have to write them.
So I may get myself into too deep a ground here that I may get tripped up here, but even like with the way a lot of people implement thin provisioning is you have to allocate a certain amount of space, right? But because of the 0 detect feature we have, I think there's a difference in the way we actually even provision a thin LUN.
Yeah, well, on the VMware side, your traditional disk, your default disk, is a lazy 0 thick, so it's going to try to allocate all that space automatically. It's not going to write all that data right away with lazy 0. That writes it, it allocates it, but doesn't write those 0s. But at eager 0 thick, which is the recommended disk for performance reasons, they write the 0s all the time in that. So when you allocate it, all the 0s are written. So we were able to detect those zeros and not have to write them. So when you do these at disk type, which is mandatory for some situations, it allows you to not actually have to allocate all that space and be able to conserve it. So can give you great space savings, and it's a good way to reclaim space a lot too in your environment by being able to detect any zero that gets written through the array and actually write that data.
So one more that I want to hit, and we talked a little bit about the store virtual VSA a little bit, but let's talk a little bit more about the benefits and use cases of VSA. And in my mind, it kind of seems to be a great solution for SMBs, small and mid-sized businesses, for remote branch offices, but where do you see VSAs fitting, and who should be thinking about VSAs?
Yeah, if you look at, if you're going to implement vSphere, you almost have to have shared storage these days. All the features that are there that are nice to have, which is why we're implementing virtualization, required shared storage. I was in a session today, and the question came up. The guy that was presenting asked, how many of you are using a SAN in your environment, or not using a SAN? And no hands went up. So everybody's using a SAN. You got to have a SAN to really get the most out of vSphere in that. So the VSA gives you that option of getting that SAN without actually going out and physically buying a big SAN and put it in your data center and that. So a lot of those companies that may have limited budgets, they like vSphere, they want to use those enterprise features, but maybe they don't have the budget for a big SAN. The VSA is a perfect fit for that because it keeps your footprint small, keeps your CapEx, your OpEx down, and really gives you that shared storage without having to actually have an external shared storage array.
Yeah, and with this last announcement that we just did with the store virtual VSA, there's actually 3 capacity points now, right?
Right, with the pricing of it.
So what, I forget what the official name is, but there's a small capacity point that's 3 licenses that are 4 terabytes each, and it's really going to be great price. So we haven't announced that pricing yet, but it's going to be
10
cheap.
terabytes, and I think like 40.
10 terabyte, yeah, that's right, and then there's actually 50.
50, okay.
So they've increased the limit of a VSA from 10 to 50 terabytes. That you get some pretty sizable capacities, and long overdue. People have been asking about an increased size for the store virtual VSA, but yeah, 50 terabytes is a pretty decent size license to be driving.
And if you look at our VSA, compared to some of the other VSAs out there, ours is the exact same software that's run on our physical products, our physical store virtual products. So you get all the same benefits, all the same features. With store virtual, it's all inclusive in that. So you're not really getting you're not getting penalized for using a VSA. You're still getting all those great features.
Great. Well, Eric, I think we're going to wrap it up there. Again, why don't you tell people where your blog is and how they can find you on Twitter?
Sure. Blog is vSphereland.com, vSphere-land.com. Twitter, I'm at Eric Siebert, and if you're around Tuesday and you can get into my session, it'll be Tuesday at 5 o'clock. Stop by and see it.
Great. And again, I'm HP storage guy Calvin Zito. My blog is at hp.com/storage/blog. Thanks a lot.